Hey everybody, welcome to our Friday Lunch and Learn session. This is Derek Goodwin from P9 CAM. Tim Paul from Autodesk will be presenting today.
Hey everybody, thanks for having me, Derek. So like Derek said, I'm Tim Paul from Autodesk CAM, one of the applications engineers, and I've been excited to be playing with the Inventor turning that came out just recently. I'll give you kind of a quick overview of what we're going to be working on. So hopefully this is something typical of what a lot of lathe guys are going to be doing. It's got some shoulders, an O-ring groove, a seal groove, stepped, internal bore, and then over here we're going to have a 2 3/8 by 16 threaded boss. So real quickly, what we have here is I'll kind of give you a quick overview of what we're going to do, and then I'll jump over and we'll work through the actual part. So we're just going to do a pretty typical lathe profile, drill, bore, and then I'll show you a couple different ways to do some grooving. We'll get over to the second operation, and we'll show you how to do the same thing, but also add a threading there. So the first operation, I'm going to thread it past the shoulder, and then we'll flip it over, grab it in some jaws, and do the second operation. So with that said, let's jump over to this part, and we'll jump right into it. So the first thing we're going to do is we're going to come up to the setup here. If you're in the model, you're going to jump over to the cam, and you're going to come up, and we got to set up the part. So we're going to set up the first operation, and we're going to work through these questions here. So the normal tabs, you just kind of start here and go over and answer the questions you need to answer. So we're going to start with doing selecting turning as our job. We're going to have it in the primary spindle, and we look out, and the gnomon's kind of where we want it. So the work coordinate system is centered, and the Z is facing the direction we want. If we wanted to flip that, we can just hit this and flip it over to the other side. For now, we're going to leave it because it's where we want it. And then I'm going to come down here to the model. I'm going to select that so it knows this is what we want to end up with when we're all done. I'm going to come to the stock tab here, and it defaulted to fixed size cylinder, which is actually what I wanted, but you can see there's a lot of other options. So I know the bar stock that I have is 3 3/4 diameter, and I want to start with let's say 4 1/4. So if we wanted to position this, offset from front, center, or back, we could do that too. I'm going to leave it on center. And then on the post setup, we got to give it a program name. So I'm just going to do the old 1 2 3 4 5. And here's where I like to type in, first operation. I'm going to leave it on G54. So if you guys know, 0 1's 54, 2's 55, and so on. So that's our job setup. Now we're ready to start cutting. If you click here, it kind of shows you your stock. You have some extra material here. You have some extra material to cut off the front. So ready. Generally, I'm going to come in and face the front off first. So you could come up to turning and grab the tools out of here. I've gotten into the habit of just right-clicking in this gray space and do a new operation, turning operation, face mill. If you guys hear me talk much, you'll notice that I count my mouse clicks and I try to reduce my mouse movement as much as possible. So that's a good little efficiency trick. So I'm going to click on face. Same thing, these 5 tabs, you just got to go through and answer some basic questions. I think about it as that you want to set it up to where you're answering the least amount of questions. So we're going to grab a tool. And here's the tools I have in this library. I'm going to grab this one. Yeah, that's going to be a good face tool. So I'm going to hit select. You can see here it's already kind of coming down, doing a one pass. I want to do some multiple passes. Let's say 3 passes at 30 thou. Let's do a finish pass too. So we're going to do a finish pass at 10 thousandths. and we're going to hit OK. Like I was saying before, I try to just get as few questions as possible. So you can see I didn't go through all the tabs. I start with, like Derek always says, throw the toolpath out there and see if you like it. Well, that's exactly what I wanted right there. I wanted a few passes and a finished pass. So the next thing we're going to do is we're going to profile this, the outside, and I want to profile it a little past that flange. I'm going to go right-click, New Operation. Actually, I'm going to close out my Outlook here real quick. I think I just saw a pop-up. So I'm going to do new operation. I'm going to do a turning operation in profile. And I think I want to use that same tool. So it auto-selected the last tool that I had. And yeah, I'm just going to hit OK. See if that gets me what I want. And actually, I know it's not, but I wanted to show you, kind of back into it. So I didn't want to go all the way here, and I don't want it to try to groove these. So I'll show you how to get rid of that. So we'll go back in, right-click and edit on that profile. And right here where it says Allow Grooving on your tool tab, we're going to get rid of that. So that's not going to let it come down into these grooves. And then I also want to set a confinement. So if you hover over this, it will kind of explain what a confinement is. I'm going to click on that. And I'm going to tell it I want to machine from that face to that face. Like I said earlier, I actually want it to machine like, say, 100 dowel past the back. So I'll do that and type 100. See if I have any questions coming in here. Okay, so I'm going to hit OK there. And that's what I wanted. I didn't want it to dip into here. I wanted it to machine past there. So now's probably a good time to do a first simulation. Make sure we're on track. I'm going to do simulate. You can turn on your stock. I like to use material. Looks nicer. We'll speed that up. Just kind of make sure that that's what we want to get. So that looks like the part that I want. So I'm going to hit OK. And now what are we going to do next? I want to drill, take a big 1 1/8 inch drill and drill this out so I can get my boring bar in there to bore down to that shoulder there. So we're going to right-click Edit, New Operation, and Drilling Operation. Go to Drill, Tool. And you can filter by diameter if you want. I know I'm looking for this guy right here. It's big flat drill, like a U-drill or something like that. I'm going to come over to Geometry, and I'm just going to select the wall of that geometry. And that, by selecting the wall, it helps you define. If I do merge hole segments, it'll take this chamfer into consideration, so it's not trying to go into the beginning of this wall right here. So we're going to merge hole segments. And on the Heights tab, I'm going to go to the bottom of the hole. And I actually want to drill past that by, say, 200 thousandths. That way I have some room for chips to kind of bounce around in there. And on the drilling cycle, I'm going to pick just a chip breaker. The chip breaker is going to take these 280 thou PEX. I actually want to make that a little bit smaller. So I'm going to right-click in there. I'm going to edit the expression. I want to make it, let's say 10% of that tool diameter. I want my tool PEX to be, yeah, that's about right. And then the accumulated PEX depth, every time it comes to remove the chips, I want that to be a little shallower too. I want it to be like, let's say, every time it reaches the tool diameter, I want it to come out. Yeah, so that's right. So I want it to make 100 thousandths PEX, and every time it gets to, 1 1/8 inch deep, it's going to retract, pull all the chips out. There we go. So we got a good drill. Now what do we want to do? We're going to get in there and bore that out with a boring bar. So we're going to right-click Edit, New Operation, Turning, and Profile. And you can see here it's trying to just auto-selected the last turning tool that I used. So I want to grab a boring tool and grab this one right here. Click OK. And the key here is that we want to tell it we're not going to outside profile, we want inside profile. So then on confinements, you want to confine it from here to that shoulder. And then here we want to start with our clearance height. You know, we just bored an 1.125" hole in there. So I actually want to set my clearance diameter to 1 inch. So that'll get us in underneath underneath the hole that we just drilled. The inner radius is where it's going to start cutting. So we just drilled a 1 1/8 inch diameter hole. So I'm going to make that 1.125. The outer diameter, where you want to finish the cut. So I'm going to just do a selection. I'm going to grab that wall right there, because that's the final outer diameter that I want to cut. In our passes tab, everything looks good. We're going to make 40 thousandths passes, and we're going to have one finish pass. So hit OK, and see, kind of like Derek always says, see what you get. See if that's what you want, and that is what I want. Actually, I would change that. Let's make our finish pass like 10 thousandths. So there you go. So we have that. Now we're going to, well, simulate it one more time. It's kind of how I would work through it. I would do a couple, simulate, do a couple, simulate, make sure everything's kind of going the way I would hope it would. I'll tell us if we're going to get any, if everything's working right. So I wanted a little bit of a clearance hole in there from the drill. The bore came through there and did what I wanted. So looks like we're good. So hit close. Now we got some grooves we got to make before we head over and do the second operation. So first I'm going to do this kind of seal head groove here. So I'm going to hit New Operation, Turning. There's a couple grooving operations. We're going to do this one because I have an 1/8 inch wide grooving tool. And that's a wider groove than that. So I'll hit Groove, with Tool. This guy right here. Hit Select. And we got to confine it because we don't want it to try to groove the whole thing. I'm going to just confine it between here and here. I'm going to hit OK and see if that gets me what I wanted. Yeah, so it gets me a tool path like I wanted. I'm going to just confirm that we have a finishing pass. So it's going to go in there and rough it, and then it's going to go in and finish it. So that's what I wanted there. Now we have to groove this. Now this is only as wide as my tool is, which is actually perfect. So I'm going to do a new operation, Turning, Single Groove. So it kept my grooving tool in there. I'm going to go to the Geometry tab. I'm going to grab the front edge line right there. And you see how the tool path kind of put it down the center. When I touch my tool off the, I set it off of the back. I'm going to do that. I'm going to hit OK, see if that gets me what I want. Now here's a little trick. If you don't want to go back in and simulate that whole job, you can do simulate. You can turn off the stock and turn on this tool path, and just show the points. I can come down here and pick that point, and it'll show you that's what I wanted. I want my tool to come down there and make that groove. So that's a handy little tip. This comes in handy for a lot of other situations too. So, I think we're done with the first operation. So I'm going to orientate it, and I'm going to simulate it. Pick that up and hit play.
Hey Tim, while you just simulate that, hey everybody, if you've
So,
got any questions, this would be a good time to take a quick break and answer any questions you have about the first side of the part. I had already answered a question for Jeff about what version we're working in. So today's presentation is actually in the Autodesk Inventor HSM product. And I know some of you like to come on the webinars who are also working in the HSN Works SolidWorks product. So this software looks a little bit different, although very similar. But I would say that some of the newest things that we are doing in Lathe have already been incorporated here. So particularly this Heights tab, just seeing Tim's demo there, I really, really like that. I'm looking forward to seeing that move over into SolidWorks product as well. So let's see if we've got some questions here. I see inner chamfer. So I have a question from Brian. Looks like maybe the bore chamfer there is not
missed
cut.
it.
Okay.
Yeah, that's a good eye. So let's see. Let's see if we caught it with the when I did it earlier. So I got it when I did it earlier. Oh, I know what I did. Here's exactly what I did. If we go here, here's what I did. Is I defined the outer diameter only by this wall. So if I was smarter, I would have allowed it to go beyond that wall. And this should do that. So I gave it 70,000. So now you see the tool wrap up there. That was a good eye. I'm going to simulate that again and see how this live TV works.
Yeah, no, that's perfect.
Yeah.
So we get to see how we do it. Now, I wonder, can you just try that one more time? What happens when you just select the edge that defines the outer edge of that chamfer? Would that give you the same result?
Great. We're going to find out.
So this is a new tab for us. Yeah, I like this.
Yeah, so what happens if I grab that? I didn't define it. Sure seems like it should. I will play with that, and because that sure should let it just grab out there, but you see this didn't move.
Mm-hmm.
You know, we wanted that to move with it, and it didn't. So I have to get a hold of the development team, or maybe I'm doing something wrong here.
Well, I know that Brian and I were on a screen share yesterday, and we were occasionally having trouble selecting from there. So there may be something that we're still just going to work on. Yeah.
Great. Yeah. So it looks like that solved that issue. You have any other questions?
So far, so good. No, it looks good.
Great. So we're going to move over to the second operation here. So now we're going to, as we already saw with this profile, machine past the surface. Now we're going to hold on to this big surface with some jaws. We're going to machine up to this surface. And we're going to put that, what I said, 2 3/8 by 16 thread on there. So we need to make a new setup for that. So we could go in and do the setup the same way we already did, but knowing that the stock and the model and all that is where we wanted it, I'm just going to come up here and hit Control D, or you can right-click and duplicate that setup. And all we have to do here is come in and edit the setup. So now we want to flip the Z over to here. So what we're going to do is hit Flip. And the model's already selected. The stock's already defined. This is where you'd want to do a second op and maybe rename that program. So kind of efficient little way to do that. You can delete all these if you want it, or just keep what you want. For me, actually, I think I want to use all the similar strategies. I just want to get rid of those grooving tools. So if we come into face, we should be able to just regenerate the facing tool. That gets us that. With the profile, I think we should be able to get away with just redefining from here to here, making that 0 for the confinement. And hit OK and see if that gets us what we wanted. So yep, that's what I was hoping for. Drill We want to use that same drill to come in here, now drill past that shoulder. So I'm going to cancel out the geometry I selected. I'm going to grab that hole, or that wall. And I do want to drill past the same amount, so I'm going to hit OK. So we kind of quickly just made that hole. We want to use the same tool to bore out that bore. So for the confinements, I'll pick here, and then I'll flip it over and pick there. And then let's drill past the back by, not drill, but we'll bore past the back by 100 thou. Hit OK, see if that gets us what we were hoping for. It did. Actually, we should have, so if we look in here, the passes tab, our outer diameter really should just be that wall, right? It should be 0. That's far enough to see that it was a model. So we had it, bigger, and it only machined out to the model, but I'm going to redefine it as that wall. That gets us that. And so now we're going to have to profile this outer profile, right? We didn't make this little groove here, so we can give some relief for the threading. I'm just going to pick another tool that I can do that in one pass with one tool. So I'm going to pick this tool because it'll get down back there, and then I'm going to allow it to groove. Before I showed you how to turn the groove off, I'm going to allow it to go down in there. And see if that gets us what we want. Yeah, so now we got down in there and come off. Yeah, that's more of what we want before we go into threading. So let's simulate it real quick before we get too far ahead of ourselves. I'm going to hit Control Select. So I'm going to hold Control. I'm going to select both of the jobs, or both of the setups. I'm going to hit Simulate. And we'll do that. Looks like we're ready to thread. Made pretty quick work of that. So let's throw a threading, looking at my notes to make sure I didn't miss anything else real quick. Yeah, so we're ready to thread. So we're going to go New Operation, and use a turning operation. We're going to do threading. Obviously, we need a threading tool. So I have this threading tool right here, single point threader. Oh, you know what? Did you guys see how that stayed over there? I'm going to hit cancel because this is a good point. Because I just duplicated that, if I would have started a new setup, it would have made it the default. But if you see this checkbox up here, anything new you add is going to add what's the default. So if you left click on this, then right click, you can either hit Shift D or you can just change that to your default. So now when we add a threading operation, it's going to add it to the second operation. So I'm going to do a new operation, go back to that, do a new operation, do a turning, come down and do threading, and then grab that threading tool. And see, now you see it on the correct side. Now we're going to go into the Geometry tab, and in the Geometry tab, I'm going to click this surface because that's the surface that I want threaded. Then we're going to have to do some confinement changes because I don't want it to lead off that much, and I actually want it to go past this backside. So this default, not really sure where it came from, but we're going to type in, we'll start with 150 in front of it, 150 behind it. Yeah, that looks like what I want. The bottom thread still gets past it. I might do 175. I'm going to hit OK. And no. I'm getting ahead of myself. So we have to define the thread depth. And this is where you're going to find some info in your machinery's handbook. We're going to do 37 thou deep. And our pitch, because it's 16 16 threads per inch is going to be 0.625. Take a number of step downs. Let's make that 3 and hit OK. So I have 3 step downs. Looks good. So control, select those. We're going to simulate it one more time. I like to speed it up because I just really want to see if my end result is what I wanted. And it looks like that's what we want right there. Do we have any more questions? Did I race through that too fast, Derek?
Yeah, hang on. I was trying to turn on my mic. Yes, you raced through that too fast, Tim. So now that we see that you can actually program a part like that in 28 minutes, while you're talking, not bad. Yeah, it's a quick program there. No, it's perfect.
Okay.
Yeah. So, hey, everybody, now's your chance. If you've got some questions, go ahead. I mean, we've got this done kind of early. We can head back and grab some lunch, but we're here now. So if you have questions, go ahead and ask them.
You know, what I can do while people are asking questions is I recently had people ask if in the same workflow, if you can go right to a milling. You know, so let's say we had some features out here, which we don't on this part, but you know, a lot of guys don't have live tooling lathes. So I was just at a shop where they would do a lathe part, and then they would have to jump over to a whole nother setup and run, you know, milling. Well, right here, all you have to do is just do a new setup, and you can go right into milling. So you just set up your part the same way we just set it up. But you would just pick milling, and then you would go through and define your milling operations. So it's nice that it's all in that same workflow. And if you do have live tooling, then you would just program it basically like a mill inside your mill turn setup.
Right. Perfect. Well, here's one question, and I'm not sure of the answer to this yet either. In the new Inventor HSM lathe product, do we have the compare function under stock simulation?
So I failed because in my notes, I'm sure that I had, let's simulate this first job. This is a tool that I use all the time. So we're going to orient that and show part comparison, and stop me if I'm thinking of something else. But actually what I do is I simulate it, and then I go and turn that on.
I see.
So then it shows me, you know, it might have been a better example is to simulate everything up to those grooves. But yeah, now you show the part comparison, and it'll show you basically this whole backside needs to be done. What might be a better example is if you were programming down through there and went to simulate and you hadn't done the grooves yet. This is probably more how it's useful to me. You know, so I machine everything. I think I'm doing pretty good, and then I turn this on, and this is where I go, oh man, I forgot this groove here and this groove here. So in blue, it's showing, you know, this is still just stock material. You can see the backside is obvious because we haven't machined that in the second operation. But
right.
Yeah, it works really good.
And that's a good point, because a lot of times when we think of compare, we just think about seeing the gouges on a part if we make a mistake. But sometimes you miss a feature and you forget a feature, and that's what Tim's pointing out right there. So you know, that can really help out, like if you're machining a plate with a ton of holes and you missed a few.
So yeah, in my last job, and we would have so many, you know, 100, 200 features, you know, little tiny features, and it's really easy to forget to come down and do a finish pass on some obscure feature. So that was a good way to kind of root out what you forgot.
Right. Okay, well, I've got a question here coming in from Brian. Let's see. I found when I clicked make sharp corners when profiling the simulation, when profiling, the simulation showed sharp corners, but when I made the part, it actually made a small radius. Any idea what's going on here? Is the toolpath shows an arc when it starts the cut while finish profiling a face or a body?
Probably best to grab your file and look through your file, but I'm going to take a guess and say that I'm willing to bet. I worked through this problem with someone recently, and I'm willing to bet it's how, if you go into, so sorry, let me back up. So I went into my tool library, and I'm willing to bet it's how the tool's set up. So if we go to setup here, it's how this is set up here in the compensation. So this is driving the tool path off this point, where the this straight and this straight come together.
Mm-hmm.
So more than likely, and let's have you email Derek the file, and we'll work through the file. But so we had a similar issue with the customer recently, and it was how the tooltip was set up.
Hmm. So that would really also require some kind of a setup on the machine tool controller.
Yeah.
Right? So you'd need to put your radius. So it's possible that the radius on the machine controller needs to match the radius on the insert here. Yeah, if you want to bring that back up, and I'm kind of probably going a little bit off topic, but we could talk about it for a second. So if you bring up that tool profile real quick, and I think we're just making a point on that tip tangent. So when you come up, so as you know, many of you know, but some may not know on a lathe, but basically you see that intersection point. So when you're turning an outside diameter, the radius on the insert does not matter because the insert will clean up. And when you're turning a face, the radius on that insert does not matter. But if you're turning a chamfer or a fillet radius, then the radius on your insert really does matter because that cutting point changes as you move around on a chamfer. So it's kind of to Tim's point there, there's definitely a possibility that the issue is based on the radius of the insert and whether or not that's timed with the radius that is on the machine controller, because on a lathe you will put in your diameter and your Z direction tool length offsets, but you will also enter in that tool insert radius into the offset register.
Yeah, explain better than me. Thanks, Derek.
It's been a while since I ran a lathe, but I remember it's important.
Yeah, it's same with me. It's been 4 or 5 years or so.
Yeah.
Last note, I mean, if, like Derek was saying, I don't have a lot of inventor turning time. It just came out, and all of these features are very similar to our HSN Works. So if any of you guys are using or thinking about using HSN Works or Inventor, luckily for me and Derek, a lot of the functionality is the same. So.
Yeah, good. Well, how many hours do you think you have so far using Inventor HSM Lathe?
My boss would probably like to hear a lot more, but I probably have, let's say 3 or 4, to be honest.
Okay.
It's not as much as I should, but luckily, like I said, it translates really easy. Mm-hmm. I have a little bit more on the HSN Works side. Mm-hmm. So a lot of the features are the same, and there's actually some improvements, like you were saying in the heights tab, mm-hmm. For the whole place. But just the naming, the naming actually makes more lathe sense than it does in HSN Works. Mm-hmm. And I think they kind of pushed it out to Inventor to see what the feedback was, and I think most people like the heights descriptions better here, so they're planning on pushing it out to HSN Works soon.
Yeah, good. That would be my feedback too. I saw it for the first time yesterday, working with a customer on on a program, and I didn't quite get it at first. You kind of illustrated it for me, and I fully understood it once you showed. Maybe you can bring that up one more time, and we'll just go through those three.
So I think about, I kind of had to learn it the same way, but it's, think about it in our milling. This is the highest. This should be the highest point. This should be the lowest point. And it's the same way in lathe. This should be further away from center, and this should be closest to center. And actually, no. So it flip-flops for outer versus inner.
Mm-hmm.
But this should be, the inner radius should be the part you're actually wanting to cut down to. The outer radius should be the part that it starts cutting at, and then your clearance should be, further away than this. If you go to the boring cycle, this is where I just had a customer that got turned around because I think he'd been doing a lot of outside profiling.
Mm-hmm.
Well, in boring, the clearance goes to the inside, but it stays on that same trend. So this should be close to center.
Mm-hmm.
It should be furthest away from center.
Mm-hmm.
And then this should be where the start cut, it starts cutting.
Mm-hmm.
So this should be your final diameter, final cut, and this should be where it starts cutting.
Right.
Can I explain that? Okay.
Well, yeah, and I think if you click on them again, just to highlight, I like the way we have those highlights. So that's the what's improved here is that they flip it. So in HSN Works, basically the heights tab is the same whether you're cutting outside or inside, and they've improved this to flip that menu for you when you're boring. So go ahead and give feedback to the team. I, for one, would certainly love to see this functionality in HSN Works as soon as possible.
Yeah, good. One thing I didn't hit on, does anybody have any other questions?
No, looks like we're good.
So if we had, I was thinking if I have a file readily available. Let me just jump into it. If we had a milled profile here, somewhere, on this surface, and you just want to lathe it and then put it in the mill later, it is important in your setup to click this spun profile. That'll make it only look at the profile that is spun. So if you want, it's not going to look at this dip. If you had a milled surface here, it's not going to go in and look at that. I can give you an example of a turn part I was working on here. Something like this. If you're in the setup, make it a little more viewable here. So if you're in the setup, and if you don't turn this mill spun profile on, well, let's see what happens. You can see this the blue outline. It's not all the way up here like it needs to be. So if your profile's cut, you're going to come all the way down to here. So it's a nice little easy feature while you're setting up the job. You just hit spun profile, hit OK, and if we regenerate that toolpath, you can see how this blue cross section actually comes out to the outer diameter. It's like the spun profile. I think the name makes it pretty clear. So if you're doing any mill, whether it's mill turn on the lathe or mill turn where you turn it in the lathe and then go over to the mill, make sure you click that spun profile so you get a good profile for your tooling. Does that make sense?
Yeah, absolutely. It's a great feature.
It's a better workflow than we had in HSN Works. And the nice thing here is, I don't know how much you've played with it in Works, but the nice thing here is if you change, it's all parametric, so if you change this model and the spun profile changes, this will update with that, where in HSN Works, on a part like this, if we change, we're using a spun profile here, if you change the model, the spun profile doesn't change with the model.
I see, right.